Dashboards timing out during peak hours. The warehouse was in standard mode with too few clusters, causing queries to queue up. Here's exactly why. Welcome to this deep dive into Snowflake's architecture. By the end, you'll understand the 3 layers, virtual warehouses, cloning, time travel, and best practices to avoid common pitfalls. Covers what you need. Snowflake is a cloud-native data warehouse that separates storage and compute, allowing independent scaling. It offers features like zero-copy cloning, time travel, and multi-cluster warehouses. Think of it like a library with separate reading rooms. Snowflake's architecture has 3 layers: database storage, which holds your data compressed in columnar format; compute, the virtual warehouses that run queries; and cloud services, which manages metadata, security, and query optimization. This separation lets you scale storage without affecting compute and vice versa. You can view your warehouses with Show Warehouses and check your current sessions warehouse with Select Current Warehouse. The storage layer stores all data in compressed, columnar format in cloud blob storage. Data is automatically partitioned into micropartitions ranging from 50 to 500 megabytes, enabling efficient pruning and parallel processing. Time travel allows querying historical data. We create a table, insert data, then query it as it was exactly 5 minutes ago using time travels at offset equals -60*5. Syntax, and finally drop and undrop the table. When a query arrives, it's handled by a virtual warehouse, the compute engine. You can scale it up by increasing size or scale out with multiple clusters to handle high concurrency. It can auto-suspend to save credits and auto-resume on demand. This code creates a warehouse with auto-suspend after 300 seconds, auto-resume, and multi-cluster scaling from 1 to 3 clusters. You can alter size, suspend, resume, or drop it. The cloud services layer is the brain. It handles authentication, metadata, and query parsing, turning a user query into an optimized plan before handing it to a virtual warehouse to execute. It also provides views like information schema and account usage. You can query metadata from information schema, view query history, and check warehouse metering from account usage to monitor performance and costs. Zero-copy cloning starts with a source table, creating an instant copy without duplicating data. The clone shares storage until changes are made, making it perfect for development and testing, and it also supports data sharing. We clone a table and a schema, then create a share to grant access to another Snowflake account. Data sharing allows collaboration without copying data. Follow best practices. Start a query on an XSmall warehouse, use clustering keys for tables over 1 TB, leverage result caching to reuse cached results for identical queries within 24 hours, and list columns explicitly to cut storage bytes scanned. This shows creating a clustered table, using result cache, second run is faster, and creating a materialized view for pre-aggregated data. Security is RBAC. A role holds privileges on each database object. Add network policies, encryption, and MFA with SSO to lock down access. This code creates an analyst role with select privileges, creates a user with that role, and sets a network policy to restrict access to a specific IP range. The root cause: the warehouse was set to standard multi-cluster mode with only 2 max clusters. During peak hours, concurrent queries exceeded capacity, causing queuing and timeouts. The fix: each query hits the load balancer, now in auto-scale mode with a maximum of 10 clusters. Queries are load balanced across Cluster 1, Cluster 2, and Cluster 3, eliminating queuing and delivering success. Standard scaling with a low max cluster count, like 2, queues queries under load because it adds clusters conservatively. Switch to auto-scale instead. It immediately adds clusters when concurrency spikes, so unpredictable workloads never get stuck waiting. To debug, check warehouse size and scaling with Show Warehouses, review query history for long-running queries, and monitor warehouse metering to identify bottlenecks. Time for interview questions. 3 layers, zero-copy cloning, and data recovery with time travel up to 90 days and fail-safe for 7 days. FAQs demystified. Snowflake separates storage and compute, handles concurrency with multi-cluster warehouses, and uses micropartitions, those small immutable files up to 500 MB, for efficient data processing. Key takeaways. Snowflake's architecture separates storage and compute. Virtual warehouses provide elastic compute, zero-copy cloning enables efficient collaboration, and time travel aids data recovery. Thanks for watching. The full article and code examples are covered in detail at thecodeforge.io.